Hello, I am Jay Prakash, lecturer from Computer Science and Engineering Department, Government Polytechnic for Women. Okay, now let us start session on the Unit 2, the Machine Instruction and Program. Okay, so assembly level language. So what happens? The computer cannot understand the human language. So the 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 language has to be converted into machine level language so that the computer should understand the data. Okay, because the computer stores the data in the form of binary form. We generally use a symbolic names to write the program. A complete set of symbolic names and the rules for their use constitute a assembly language. A set of rules for using the mnemonics in the specification of the complete instructions and the program is called as syntax of the language. So syntax tells the rules and regulations, how the data has to be, present. So it is a mnemonic. So it specifies the complete instructions, what it has to be. Okay. The program written in the assembly language can be automatically translated into the sequence machine instruction by the programmer called as assembler. So whatever the data that is written in the assembly level language has to be get converted into the another form. So assembler acts as a mediator which converts the assembly language into human readable form. The user program in its original alphanumeric text formal is called as source program. So whatever the user writes the program, that is called as source program, and the assembled machine language program is called as object program. So object program converts the is a conversion of the source program. So that is easily understood by the computer. For examples, move r naught comma sum. In this, the term move represents the op code. Move is nothing but operation code, and R naught is the register. The term move represents the opcode for the operation performed by the instructions. And then add the 5 to the contents of the registers R3. Here, the value of the 5 is added to the R3 and put the result back to the register R3. Okay. So this is how the assembly language will work. So whatever the program we write, that is in the source program, the assembler converts the source program to the assembly level language, which is nothing but the object program, and then the object program is easily understood by the computer. From the computer, it will perform the task. Again, it will be converted back to the source to the user readable form. So this is how the source program will convert it to the object program, and object program again converted it to the source program. Okay, that will be help to the execution so that the user can easily understand the data. Assembler directives. The directives are the assembler commands to the assembler concerning the program being assembled. So it tells how the data has the program being assembled. The commands are not translated into the machine opcode in the object program. So here the commands are not translated into the machine operational code in the object program. The assembler directs consists of many commands. Okay. So equation, origin, data word. So these are the operations that is going to perform here. Okay, and the statements that generate the machine instructions. So the start and the loop operations, these are the operations that are going to perform, and these are the opcode, and this is the address locations or the data information. EQU. So let us take an example. EQU is nothing but equals. It informs the assembler about the value of the identifier. It will tell us the value is equal. Okay. For example, sum equal to 200. So whatever the means, it informs the assembler that the sum should be replaced with the value of 200. So here the sum value is replaced with the value 200. So the sum 200 value will be get into the sum. Okay. That is why the EQU command represents the equals. Okay. Origin tells the assembler about the starting address of the memory area to place the data block. So where the starting address of the memory area takes place, that is represented by the origin. The 204 instruct the assembler to initiate the data blocks at the memory location 204. Data word. The data word directive tells the assembler to load a value into the location. So where with the data has to be loaded to the location is represented by the data word. Example, n data word 100. It informs the assembler to load a data 100 into the memory location already mentioned 204. Reserve. The reserve directive is used to reserve the block of memory. We have to reserve the block. Okay. Examples, num1 reserve 400. It declares a memory block of 400 bytes to be reserved for the data. So 400 bytes is reserved for the data. Okay. End. The end option directive tells the assembler that is the end of the source program context. That is the end. Okay. Next, return. The return directive identifies the point at which the execution of the program should be terminated. So where the program should end, that will be mentioned by the return, because it will terminate the other execution and will return back to the location where it is mentioned. Another statement that makes the instruction or data being placed in the memory location may be given a label. So we can mention a label, okay, assign a value equal to the address of that location. Next, the general format of the statement. A statement can be represented by following format: the label, the operation, the operands, and the comments. There are four blocks: label, operation, operands, and comments. Label is an optional name associated with a memory address where the machine language instruction produced for the statement will be loaded. So it represents the name associated with the memory address, that is called as label. Operational field. The operational field contains the opcode mnemonic of the desired instruction of the assembler. So operational field mentions the operation that is going to be get performed. The operational field, it contains the addressing information for accessing one or more operands. So it contains the addressing information for accessing many operands. Next one is the comment field. The comment field is used for documentation purpose to make the program easier to understand. So this is the general format of the statement. The statement includes a label, which is a name, and the operation, which is the operation that is going to perform, example, addition, subtraction, multiplication, division, anything. The operand field represents the number of operands that is present in the instructions, and the comment field will help the users to understand the program so that he can understand and write the program in a proper way, or execute the program in a proper way. Assembly and executing the programs. How the assembly and execution of the programs can occur. Programs written in the assembly language are automatically translated into a sequence of machine instruction by the assembler. This has already been told. So assembler acts as an intermediate so that the source program is get converted into the object program. So assembler converts the source program into the assembly level language. Okay. Next, the assembler program replaces. So what happens? The assembler, what are the actions that is done by the assembler? The assembler replaces all the symbols denoting the operations and addressing modes with the binary codes used in the machine instruction. So the computer understands the binary form of the instruction. So assembler replaces the all the data into the object program that will be easily understood by the computer. It replaces all the names and the labels with the actual values. So whatever the values that is present, it will be replaced by the assembler. It assigns the address to the instructions and the data blocks starting at the address given in the origin directive. So wherever the address location, obviously it will fetch the data from the particular location. It inserts the constant that may be given in the data word directives. So whatever the constant values that is assigned by the data given in the data words, it will be added to the particular locations. It reserves the memory space are requested by the reserved directives. So if the memory space is allocated for any variable or any term, it will be get reserved for that data. There are two passes for the assembler. So before executing the program, there are two passes. First pass, work out all the addresses of the labels. So first we have to find out the addresses of the labels, the location where these labels are present. As the assembler scans through the source program, it keeps track all the names of the numerical values and then correspond to the symbol table. So this is the first step where the addresses of all the labels is found out, and then scans the source program and keep track of all the names of numerical values that corresponds to them in the symbol table. In the case of second pass, the generate a machine code substituting the values for the labels. So we are going to generate the object code in the case of second pass. In the case of first pass, we find out the all the address of the labels and also keep track of all the names of the numerical values that correspond to them in the symbol table. When the name appears in the second time in the source program, it is replaced with a value from the particular table in the second pass. The assembler stores the object program as a magnetic disk. So in the hard disk, we can store the data. The object program must be loaded into the memory of the computer before it is executed. So whatever the data you stored, it will be stored in the hard disk, or we can directly copy the data. Okay, the object program must be loaded into the memory. So whatever the source program is converted into object program, those object programs should be loaded into the memory in order to execute it. For this, loader program is used. So this is a diagram which explains how the interactions will occur with the processor and the memory. So this is the internal processor bus. The bus is a line which attaches to the different components. Okay, the program counter. The program counter will help us to execute the many programs. The program counter points to the next instruction to be executed, but initially it is pointed to the first instructions. And then MAR. MAR hold the memory address registers. So it holds the address of the instructions to be executed. Okay, memory data registers. The data, the location where the address is mentioned, that data will be reside in the MDR. So Y is the temporary registers, and whatever the data that will come to the Y added with the constant, if any value is there in the constant, it will be get multiplexed and it will pass to the arithmetic and logical unit where the operations is going to perform. Okay, for example, here multiplexing, the output value is A, and then the value, another value is B. You can perform the operation, additional operation, subtraction operation, multiplication or division. Okay, after addition, we can put the result back to the temporary register like Z, and it will be passed to the register, general purpose registers, then it will pass to the processor. So whatever the instruction that is to be executed currently, that will be placed in the IR. Okay, and then MAR and MDR is found out, and what after perform the actions by the control unit and the control signals, which will decode and perform the control actions. Okay, logical operations or anything by the ALU, and then the result will be get back to the IR, and then it will move to the MAR, and data will move to the MDR, and then to the MAR, and then finally to the output output registers. So from that the data can be put back to the output devices. So this is how the execution of a program will occur. Okay, thank you.